Hello learners, in this lesson we will learn how we can interpret logistic regression. In logistic regression, it is difficult to interpret the relation between the independent variables and the probability that y equals to 1 directly because the logistic regression equation is non-linear. However, statisticians have shown that the relationship can be interpreted indirectly using a concept called the odds ratio. The odds in favor of an event occurring is defined as the probability that the event will occur divided by the probability the event will not occur. In logistic regression, the event of interest is always 1. Given a particular set of values for the independent variables, the odds in favor of y equal to 1 can be calculated as odds equal to probability of y equal to 1 given the values of x1, x2 up to xp divided by probability of y equals to 0 given that the values of x1, x2 up to xp. So we can also write this expression as this, which is 1 minus probability of y equals to 1 given the values of x1, x2, xp. So if we know the value of probability of y equals to 1 for given the values of independent variables, we can calculate odds. The odds ratio measures the impact on the odds of a 1 unit increase in only one of the independent variables. The odds ratio is the odds that y equals to 1 given that one of the independent variables has been increased by 1 unit, which we denote by odds 1, divided by the odds that y equals to 1 given no change in the values for the independent variables, which we denote by odds 0. So, odds ratio equal to odds 1 divided by odds 0. A unique relationship that exists between the odds ratio for a variable and its corresponding regression coefficient for each independent variable in a logistic regression equation. It can be shown that odds ratio equals to e to the power beta j, where j equals to 1, 2 up to p, where p is the number of independent variables. In general, the odds ratio enables us to compare the odds for two different events. If the value of the odds ratio is 1, the odds for both events are the same. If the independent variable we are considering has a positive impact on the probability of the event occurring, the corresponding odds ratio will be greater than 1. Now we will be introduced with a new term, logit. An interesting relationship can be observed between the odds in favor of y equal to 1 and the exponent for e in the logistic regression equation. It can be shown that log of odds equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus beta p xp. This equation shows that the natural logarithm of the odds in favor of y equals to 1 is a linear function of the independent variables. This linear function is called the logit. We will use the notation g of x1, x2 up to xp to denote the logit. So, the logit function is g of x1, x2, xp equals to beta 0 plus beta 1 x1 plus beta 2 x2 plus beta p xp. Now, if we estimate the parameters beta 0, beta 1, beta 2 and beta p and denote the estimators as b0, b1 up to beta p, then the estimated logit is g hat x1, x2, xp equals to b0, b1 x1 plus b2 x2 plus bp xp. So a logistic regression gives the formula to predict a logit transformation of a probability of presence of a character of interest. So the model is logit p equals to b0 plus b1 x1 plus b2 x2 plus bp xp. This is our estimated logit function actually. In logistic regression, the dependent variable is in fact a logit, which is log of odds. So logit p is also equal to ln of p by 1 minus p. So the required probability is p equals to e to the power logit p 1 plus e to the power logit p. So we can determine the probability and the odds ratio from logistic regression. Now look at the demerits and merits of logistic regression. First, look at the merits of logistic regression. Logistic regression doesn't require too many computational resources. Logistic regression is easily interpretable. Logistic regression is incredibly easy and quick to implement. So, although logistic regression is very much helpful, there are some demerits of logistic regression too. So, logistic regression is not a useful tool unless we have already identified all the important variables. It can be outperformed by the more complex situations. Logistic regression doesn't perform well with independent variables that are not correlated to dependent variables.